Okay, so for number 17, taking a look at 17, remember from yesterday, what does the negative exponent tell you to do? That it needs to move. If it is on the top, it goes to the bottom. If it's on the bottom with a negative exponent, where does it go? To the top. Okay, so let's take a look at number 17. Which ones are going to move here? X to the negative 3 and, all right, why doesn't the 2 move? It doesn't have an exponent, but it looks like it goes with this, so why doesn't that count? Brian, how come that doesn't count? Okay, what would it have to be in for it to count? It would have to be in parentheses. If this looked like this, 2x to the negative third, then you would move the whole thing. But the 2 and the x are separate. 2 is a constant, x is a variable. If it does not have parentheses, it does not go together. So the only things you move are the x to the third, the y to the second. Does the z move? No, why not?
Because it's like already there and it's positive.
It's already positive. So if it's already positive, leave it alone. So then what goes on the top?
2.
Just the 2, and that's it. Okay? So again, the only things you move are things that have negative exponents. Now, what does a negative exponent mean?
That it's not in the right place.
Okay, it's an indicator that it's not in the right spot, but what does it actually mean? What do you mean by that? Victoria just said we're going back to the left. What does that mean? So it has something to do with decimal places and moving decimal places. Good. What we're going to talk about today is exponents and scientific notation. How many of you guys have seen scientific notation before? Okay, so most of you guys have probably already seen it before, which is good. So today should be mostly a review. So if you have not seen scientific notation before, it might be new, but today should be a review for most of you. So, Francis? Yeah, it tells you how to move the decimal places. We're going to talk about just why that works for just a second. But before we do that, we're going to talk about powers of 10. So powers of 10, basically, when you multiply something by 10. So I'm sorry your slides are so weird. They don't have this on here. But this will be posted on Schoology with all the actual images. So don't worry about like copying down all the charts that are on here. It'll be on Schoology if you want it. But take a look for a second. If you have something like 3 times 10. What does that give you? 30. What if you have 300 times 10? 3,000. How'd you guys know that off the top of your head? You're just, when you multiply by 10, you're really just adding a 0, right? What about when you divide by 10? Yeah, you take away a 0. So if I divide by 10, 300 divided by 10 would give me 30. 4,500 divided by 10 would give me 450. Why does that work?
Because they all have zeros.
Because. Why? Because why? Because they have zeros. So would it work?
If you had like maybe a 7 or 9, it could
Give me an example. So Gabe just said an example, like let's say you said a 7 or a 9. So if you had like 4, 5, 7, 9, something like that, right? And I said divide it by 10. You can't just knock off the 9, right? Why not?
Because it doesn't like 9 isn't like equivalent. It doesn't go to it. You know what I'm trying to say?
I think I know what you're trying to say, but I want you to try to flesh that out a little more. So Gabe said it's not equivalent to 9 and 10 aren't equivalent, whereas what was equivalent up here that allowed us to do it? Adela?
9 can't go into 10.
Okay, it doesn't go in evenly, whereas 10 goes into, like when you have a 0 on the end, it's like just having that 10. So could you do this though in your head?
No.
Sure? Well, one, you could technically probably do anything in your head. You just might make a mistake. But I bet you guys could do this one in your head. Let's do it not in our heads and see what we get. 4, 5, 7, 9 divided by 10. How many times does 10 go into 45? Alfonso, don't spoil this for me. This is my big moment, all right? I'm impressed. How many times does 10 go into 79? What do I do now? How many times 10 go into 90? Okay, so what happened to go from 4579 to our answer? All of a sudden there's a decimal in there? But it looks like all you really did was do what? Move a decimal over one time. So dividing by 10, if it ends in a 0, you just knock off a 0. If it doesn't end in a 0, it's the same thing as just moving the decimal over one time. So then if I said 4, 5, 7, 9 divided by 10 squared, what would that be like? Victoria? You would move it over 2 times, right? So you're dividing by 10, and then you're dividing by 10 again. So you move your decimal over once, twice, and you end up with 45.79. So a power of 10, we work in a base 10 system. And what a base 10 system means is when you guys first learned your decimal places, we said you probably had a teacher tell you, like, this is the ones place, this is the tens place. When you go over here, what's this one called? Tenths. That everybody does that. Tenths. This is the hundredths, right? I'm like flashing back to when I taught middle school right now. And I was like, don't forget the ths at the end. Okay, so when you're in the decimal spot, you add a th because the number is getting smaller. But each of these places is a value of 10, right? So this is the ones place. How come we don't go to the twos place? Because you can't, but why not? Not necessarily, because it goes by 10. When you have, how many digits could you put here? You could put a 0 or a 1 or a 2 or a 3 or 4 or a 5 or a 6 or a 7 or an 8 or a 9. So how many options do you have there? 10, 10, because you could put a 0. All right, which is why each of these place values counts in tens, because you have 10 options you could put here. Then you have 10 options you can put here, and 10 options you can put in each place value, right? So we have a base 10 system, which is why dividing by 10 or multiplying by 10 is really easy. You just have to move your decimal over, because essentially you're just saying, I want to move from this decimal place to this decimal place, or I want to move from this decimal place to this decimal place. Go ahead, Francis.
So if it were a negative exponent,
yes.
it would go backwards?
Exactly. So that's why we talked about negative exponents yesterday, because we talked about what would happen if you have a negative exponent. Essentially, instead of getting bigger, the number is just getting smaller. So instead of moving over one way, you move over the other way. And we're going to talk about which way you move and what that looks like in just a second. Okay, so how would I write this? 10 to the 5th. What would that look like? It would look like 10 times 10 times 10 times 10 times 10. What's 10 times 10? 100. What's 10 times 10? And then I've got another 10. Okay, what's 100 times 100 times 10?
100,000.
Does anyone have a calculator and can check that?
Ain't no phones out.
100,000. Perfect. So 10 to the 5th power is 100,000. All right, 10 to the 5th power is 100,000. Now, what would 10 to the negative 4th power be?
Oh, would it be negative 10, negative 10?
It wouldn't be negative 10, negative 10.
No, it
It would turn to a positive.
be like you just do 10 times 10 times 10 times 10, and then the answer would be negative.
Not quite. Think back to what we did yesterday. Micah? Put it in a fraction, and it's what? Guys, the 10 is not negative. The exponent is negative. The 10 is not. So the 10 stays positive. It just has to move to the bottom. Remember, don't forget everything that we did yesterday. The negative exponent tells you that it just moves to the bottom. So now 10 times 10, 10 times 10, this is really like 1 over 10,000. Now, is this number really big or really small? Really small. 1 out of 10,000. Think back to the pizza Gabe and I were going to share yesterday. If I have a pizza and it's cut into 10,000 pieces and I give you one of them, is that a lot of pizza? No, that's a... You could like not even see that pizza slice, right? So that's a really small number. So that means if something has a negative exponent, is it really big or really small? Really small. If something has a positive exponent, is it really big or really small? Really big. Okay? All right, so take a look at these then. Let's try to simplify these. So if I want to do 1 over... Yes, I want 3 people to come up to the board. Can I do someone to do number 1? Gabe, Victoria, and Francis. Pick anyone you want. I don't care. Okay.
I call 1. Wait, you gotta go 1 at a time because you'll change colors.
That's fine. She just wants number 3 anyway.
I want to do... I told you that we're going to change colors.
I think number 3 is the hardest.
Me too. Perfect.
That was so hard, my head hurts now.
I'm glad you made it through.
Can I have a calculator, please?
Sure.
I know what to do. Why is it?
Why are you going down, Vernon?
I'm not going to.
I mean, yes, you are.
Yes, you are. Sorry, okay, going down.
There was this one time where Miss Anderson, she was like trying to erase it, but then she just kept on writing like.
Because if you hold a pen when you have the eraser, yeah, I do that all the time.
Why are you? It's not okay.
All right.
Now is my time to shine. You know what I mean?
Oh no.
Let's go, big. I have to give special thanks to my boy Anthony, my man Alfonso.
I teach you, and I don't get a single shout out.
Shout out to Miss Bird.
Thank you.
Teaching me algebra.
Shout out to Miss Vernon because she's the one that even let me up here.
When we graduate.
Good. Perfect. Okay, guys, eyes up here. So keep going. You keep going. So what did Gabe have to do there because it's 10 to the negative third? Yeah, so he put it in a fraction. How come there's a 1 on top? Why is it supposed to be that way?
Because if it's not there, then you're gonna like think that it's like a 0. I mean,
Yeah, you need a placeholder, right? So you need a placeholder, so we use 1. Good.
1 is so special. Well, that's a big.
Where'd your numerator go? Where'd your numerator go? Good. 1 over 1,000. Perfect. So 1 over 1,000. All right. Now, the reason that we're talking about 10 so much is because we use 10 when we're doing scientific notation. So I want to talk to you guys about scientific notation. This is what we just did, basically, but backwards. So if I want to write these as a power of 10, that means I want this 10 right here, and I just need to figure out my exponent. For this one, is this going to be a positive or a negative exponent? Why would this be a negative exponent? You're going because this is a really small number or a big number? All right, this is really important though. So take a look at this. So I know that you want to just say, okay, how many zeros does it have? You cannot just count the zeros because you want it to end up with 10. So 1, 2, 3, 4, 5, 6, 7. Is that 10? So I need to move it one more time, so it ends up being 10 to the negative 8th power. Okay? So it's 10 to the negative 8th power. Because you're not just counting zeros, you're counting spots. In exponents, this doesn't count, like this exponent does not count the number of zeros you have, it counts the number of spots that you move. So if you've got this number, 0.1234561, and you want it to look like 10, you have to move your decimal 1, 2, 3, 4, 5, 6 spots. Then you have to move it again, and then again. Because if I want it to be 10, I need it all the way over here. If I only moved it 7 spots, it would be 1.0. Okay? So I've got to move it negative 8 spots. Now here, this would be 100 to the what? This would be 10 to the what? 100 is 10 to the what power? 2 power. All right, 100 is 10 to the 2nd power. Okay, so with scientific notation, what we're essentially doing is taking a number and multiplying it by 10 a certain number of times. So it allows us to write really big or really small numbers multiplied by powers of 10. I'm going to skip a couple of slides here. All right, so scientific notation, the biggest thing that people make mistakes on is writing their... what's the word I'm looking for? Writing their first number in the wrong format. If it's proper scientific notation, that means you should only have 1 digit to the left of the decimal place. All right, so everything should be in the ones place. So that means this number, 5.91 times 10 to the 8th, this is called scientific notation. It's always a base 10, and it's always multiply. And if I'm looking at this right now, is this a really big number or a really small number? It's really big, because I'm multiplying this number by 10 how many times? 8 times. So I'm doing it times 10, times 10, times 10. But that would take me forever to do on a calculator, and I don't really need to do that, because this is also just telling me how many times I do what? Move my decimal. Because remember, what we said before is multiplying by 10 is really just like moving your decimal place one way or the other. So in this case, since it's getting bigger, we move it to the right. So this number like this, 5.91 times 10 to the 8th, would look like what if I expanded it into standard notation? So 5.91, and you move it right 1, 2, 3, 4, 5, 6, 7, 8 times. So how many zeros do you add? All right, so does this tell you the number of zeros or the number of times you move it? Number of times you move it. You cannot just add 8 zeros, because there were 2 spots here that we had to move over. So your number ends up being 591. So if I put commas in, this is 591 million? Million. Almost billion. You're like, well, half a billion. You're close to, if you had one more zero, it would be billions. All right. So scientific notation will always be in this format. If it's not in this format, it's not correct. So you always need one decimal point to the left. Sorry, one number to the left of your decimal point. Okay, so how could I write these two in scientific notation? I need 2 people, 2 different people. Brian, which one, the top or the bottom? Come on up. Do you want to do one more example first? Okay, let's do one more example first. So let's say we have all right. Now, before I start, is this going to be a positive exponent or a negative? Positive, because this number is no. It's really big. It's a really big number. So that means that it's going to be a positive exponent. Even if it's not a really big number, if it's not a decimal number, it's going to be a positive. Okay, so where do I want my decimal to start? Where does my decimal always start if there isn't one in there? It always starts at the end. And where do I want it to end up? Between 3 and 5. So it starts at the blue and it ends up at the red. And then to figure out my exponent, I just figure out how many times I move it. So first things first, what's my number in the first spot of scientific notation in this case? 3.57. Then it's going to be times what? 10 to the something. Now we just have to figure out the something. So to figure out that something, I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so 3.57 times 10 to the 10th, because I moved it 10 times. Okay. Is my exponent going to be negative or positive here? Negative. So I'm going to do times 10 to the negative something. What's my number going to end up here? So I want it here, right? So 5.82. And then I just go 1, 2, 3, 4, 5. So it'd be 10 to the negative 5th. All right? So always you want one number to the left. So you move your decimal until you have one number to the left. And you have to write whatever other numbers are there. If it's all zeros, though, like we did up here, we didn't have to write 3.570000. You can get rid of all those zeros. All right? Just like you can get rid of all the zeros in the front. Okay, so Brian, you want to try this one? Yeah? You're going to do the bottom one? Okay, so that's where you want it to end up. So then what's the... Good. All right, so then what does it look like in scientific notation? You've you got those flipped. So it's 4.3.
Times 10 to the negative whatever counting power.
Good, perfect. Very good. 4.3 times 10 to the negative 8. Okay, one more person. Micah, come up and do the top one.
Can I get some water?
No. Guys, if somebody is at the board, please stop talking while they're up here.
Am I counting that?
Mm-hmm.
Okay. 1. Come on. 2, 3, 4, 5, 6, 7, 8.
Good.
Yay! Okay.
Wait, Miss Burns, is there a 0 at the end? I don't have to move one more time.
Oh, it's negative. It's not.
That would be adding another 0.
Yay!
Okay, good. So the difference between Micah's and Brian's was that Brian's was a negative exponent and Micah's was a positive because Micah's number was really large and Brian's number was very small. Okay, so they both moved it 8 spots, but Micah had to move her decimal to the right. Brian had to move his to the left. Now, I will tell you guys, I don't think you should try to do every time I go to the left, it's going to be negative. Every time I go to the right, it's going to be positive. Because if you're going from scientific to standard or standard versus scientific, the left and right reverses. So I would like you guys to just think about it as if it's a large number, it should be a positive exponent. If it's a negative, or if it's a small number, it should be a negative exponent. All right. Now, I have these 6. They're on the board. They're not on your slides. So when you go to your boards, be careful that you're looking up here. And then you guys can do the exit ticket when you're finished with that.